All right, we're going to talk about surface area today. So similar to volume, we're finding the surface area of three-dimensional shapes. With surface area, we talk about it being how much it takes to cover a shape. So think wrapping paper on a box or a rectangular prism. Another way to think about it is how much it takes to make a shape. So the material it would take to actually physically make a box. So on your notes, it asks for a practical example of volume. Just cross out volume and write surface area. So a practical example could be the amount of paint needed to cover a box. That would be surface area, or something like the amount of aluminum needed to make a can, like a soda can. So those are two practical examples that you can use. The awesome thing is steps for finding surface area are basically identical for the steps for volume. Again, first step is copying your formula after you identify what shape you're dealing with. So remember last time we talked about the difference between prisms and pyramids, and that will help you. Remember, before we go to substitution, there is a step 1B or 1.5. So that second step is calculating things like capital B or lowercase p. So we need to do those calculations off to the side with B equals and a formula, or P equals and a formula, and then B equals with a substitution, and then answer with units. So we show those calculations first. Then our second step is to substitute that capital B or that lowercase p and any other dimensions into the original formula. After that, we do our calculations to get our answer with units. Right, speaking of units here, when we're doing units for surface area, we're always doing squared units. And that's how we say them. So some examples would be squared millimeters, squared centimeters, squared inches, squared feet, and so on and so forth. Remember, when we're talking about this, we are covering a shape with squares, which is why we have squared units. Okay, so write down that remember piece. We're covering a shape with squares. All right, let's go ahead and take a look at some examples. So the first one is the surface area of a cylinder. So we identify this as a cylinder. We look on our formula sheet, and our formula sheet says for a cylinder, we have surface area is 2 pi r squared plus 2 pi r h. So we write down SA equals 2 pi r squared plus 2 pi r h. Okay, I check to see if there's anything that I need to calculate. I don't see a capital B, I don't see a lowercase p, so I can move on to substituting. I then check to make sure I have all of the dimensions for my substituting. So I need a radius and a height. I look on my diagram, I have a height, but I have a diameter, I don't have a radius. So anytime we see the diameter, we want to write a big dividing by 2, and then type 5 divided by 2 into our calculator to write that our radius is 2.5 inches. Now that I've calculated the radius, I can substitute everything into the formula. I write SA equals 2, and then in place of pi, we're using its approximation 3.14, and then we're doing 2.5 squared plus 3.14 for pi again, times 2.5. Make sure you don't square this radius, and then your height of 20. I always read my formula and compare it to my substitution to make sure I didn't forget anything. So we have the SA and the equals, the 2, the pi, the r, and the squared, and then the plus, the 2, the pi, the r, and then the h. So everything is there. Then we use our calculator to do order of operations. You can type as long as you do the exponent first and then all the multiplication. So I would do 2.5 squared in my calculator first, and then times 2 times 3.14. That gets me 39.25. Then I type in all of this multiplication as well. So 2 times 3.14 times 2.5 times 20. We get 314. We add those together in our calculator, so the 39.25 plus the 314, and we get surface area of 353.25, and those are squared inches. Okay, so our next problem that we're going to take a look at is the surface area of a rectangular pyramid. We know it's a rectangular pyramid. It's a pyramid because a majority of the sides are triangles, and it's rectangular because the other side that we see is a rectangle. Please go ahead and draw your slant height in. I did not do that on your notes. Put a right angle at the bottom of that slant height, and then label that slant height as 7 inches. So slant height is 7 inches. We're going to look on our formula sheet at the pyramid. The pyramid's surface area is 1/2 LP plus capital B. So we're going to write that formula. Surface area equals 1/2 L lowercase p plus capital B. Okay, I cannot substitute anything in until I calculate both the perimeter and the area of the base. So the perimeter is just the perimeter of the base shape. Remember, our base shape is a rectangle. So I'm going to add 4 sides together, and I'm only adding the sides that are on this rectangle. So I see 10 and 8. I know opposite sides are the same in a rectangle, so this side is 10 and this side is 8. So we would write down our addition, 10 plus 8 plus 10 plus 8, and we get the perimeter is 36 inches. Okay, then we need to calculate area of the base, so that's capital B. Equals, my base again is a rectangle, so I look on my formula sheet and find the rectangle. The rectangle says area is length times width, so we do capital B is length times width. My length and width are 10 and 8, so we substitute those in, 10 times 8, and then we get our base area as 80 squared inches. Now I can substitute everything into my original formula. I still have 1/2. My slant height is the height going down the side of the pyramid, and that is 7. And then my perimeter is 36, plus my area of my base, which is 80. So we're going to type this into our calculator as 1 divided by 2 times 7 times 36 plus 80. So let's try that. 1 divided by 2 times 7 times 36 plus 80. And that gets us a surface area of 206 squared inches. All right, go ahead and look at the shapes on the back side. We're going to look at the rectangular prism for surface area. So if you look at your formula sheet, the surface area formula for rectangular prism is SA equals 2LW plus 2LH plus 2WH. I have no capital B's or lowercase p's, nothing to calculate, so I can skip straight to substituting. I'm going to substitute in 15.2 for length, 3.5 for width. Before we do that, let's convert this 1/2 by doing 1 divided by 2 and then adding the 3. So in our calculator, 1 divided by 2 plus 3 gets us 3.5. So we're going to substitute in 3.5 plus 2 and then 15.2 for length again, 16 for height, plus 2, 3.5 again for width, and then 16 for height. Okay, if we type this in as is without hitting the equal sign until the end, it will do order of operations for us in our calculator. So we're going to type in 2 times 15.2 times 3.5 plus 2 times 15.2 times 16 plus 2 times 3.5 times 16. I'm going to double check that because I'm not sure if I did that correct. So type it in one more time. 5, 2. We get 704.8 squared centimeters. Remember, I did not say equals until I got to the last multiplication that I typed in. I hit equals at the end, and that's how I got 704.8 squared centimeters for your surface area. Okay, so taking a look at the next shape, this next shape is a triangular prism. Again, we know it's a prism because there are 3 rectangles and only 2 triangles. It's a triangular prism, which means the triangle is the base. Okay, the triangle is the base, and it is an equilateral triangle because you see the 3 marks there. If you're having trouble seeing the mark at the bottom, go ahead and make it darker. You've got a equilateral mark right there. So the surface area for a triangular prism, if we take a look at our formula sheet, is SA equals H times P plus 2B. So SA equals H times P plus 2B. Okay, again, I cannot move on to substituting until we calculate the perimeter and the area of that base. So perimeter of the base again is a triangle. My triangle is equilateral and one of its sides is 8, so that means all 3 of its sides are 8. We're going to add 8 together 3 times. We get the perimeter is 24 centimeters. And then we need to calculate capital B, which is area of the base. The base is a triangle, and that formula is 1/2 little b little h when we're doing area of a triangle. To substitute in, we're doing 1/2, the little b is 8, and the h is 3, because I have a right angle with the height of 3 and this side of 8. Anytime there's a right angle between 2 dimensions on your triangle, those dimensions are base and height. We're not using this 12 as the height because that is the height of the entire shape, not of the triangle that's 2-dimensional. So we're going to type our calculations into the calculator, 1 divided by 2 times 8 times 3, and we should get 12 squared centimeters. And then we're going to substitute everything back into the original formula. So surface area equals the height of the entire thing is 12. Remember, this shape is turned on its side right now, so this is still considered the height of the shape, even though it's laying on its side. So 12 times the perimeter, which is 24, plus 2 times the area of the base, which is 12. Again, if we type this in as is, no equal sign until the end, the calculator will do order of operations for us. So that's 12 times 24 plus 2 times 12. And then we hit equals. We get surface area equals 312 squared centimeters. The last shape that we're going to take a look at is the surface area of a cone. So if you look on your formula sheet, the surface area of a cone is pi r squared plus pi rl. So we're going to write down SA equals pi r squared plus pi rl. I don't see any capital B's or lowercase p's to calculate, so I can move on to substituting. I have SA equals 3.14 for pi, r squared, r is already calculated, so 2.1 squared, plus 3.14 for pi, r is 2.1, and then our slant height, L, is what they're asking for, which goes down the side of the cone, not through the middle. So we're going to use 6.7 instead of 6.5. Okay, so we need to do the squaring first, so 2.1 squared. Then we can multiply that by 3.14. And then we can hit add, and all of this multiplication, 3.14 times 2.1 times 6.7. Then we hit equals at the end, and we get surface area equals 58.0272 squared feet. Okay. If they ask you to round, you can. If they don't ask you to round, you can still also round, just as long as it's rounded correctly. Make sure that you ask any questions that you may have or write them down, and then move on to your practice.